In this problem, we're given a pretty complex circuit diagram. We need to assume the op-amp is ideal, and we are given a couple of voltages, and then we're asked to find V0. When we look at this, we can see that it is an inverting amplifier circuit because we have a negative on top. So we know that this voltage coming in here is going to be a Vn, and the voltage coming in this way is going to be a Vp, N for negative, which is inverted, and V for positive, which is non-inverted. Because it is an inverting amplifier, we know that from our V0, our output, we are going to have some feedback that'll go back into our op-amp like this. And these voltages will also be going into our Vn like this, and some of our Vn is going to be going down this way for the 600 kilo ohm. This is how our diagram should look. Lastly, for our Vp, we know that we have this voltage that'll be going in this way. Now that we've drawn our diagram out, we can solve our problem. We know that Vn is always equal to Vp. And in this case, Vp is equal to our V of D because it's the only thing going inside of it. And we know that our Vd is equal to 8 volts. So our Vn is equal to Vp, which is equal to 8. This is going to help us with our node voltage method. When we look at our diagram, we have one node that we can really kind of combine right here. We're just going to be looking at this node. We're going to be looking at the Vn with these voltages as well as this voltage right here, and we'll explain why in a second. If we write out our node voltage method, this is what it's going to look like. First, we start everything off with our V of N because that is the main voltage that we're looking at. That's what everything is going into. Then we're going to subtract our V of A because our V of A is going into it, as we can see, and this is all happening over the 72 kilo ohms. We're going to do the same thing for V of B, which is over the 120 kilo ohms, and the same thing for our V of C, which is over the 450 kilo ohms. Lastly, our V of N, we don't have any voltage for this 600 kilovolts, so it's just going to be V of N over 600 kilovolts. I think I said kilovolts a lot. It should be kilo ohms. Kilovolts is not in this problem. And lastly, because of our negative feedback right here, we are going to have a Vn minus V0, and this is all happening over our 180 kilo ohm resistor. Now we are going to start plugging in the values that we know. Well, we know our VA, VB, VC, and we know that our Vn is equal to Vd. If we plug all of those in, we are going to get this right here. From here, we can carefully plug all of this into a calculator, multiply it by 180, and then from this, we're going to see that our V0 is equal to a negative 2.4 volts. And this is the answer to this problem. Pretty complex looking, but actually very simple. If you have any questions about the material we covered, you can leave them in the comments below. If you want more introduction to circuit analysis, there will be a playlist in the description with more problems, and near that will be notes that'll help with any of this coursework.